Hi everybody, my name is Moses So. I did my project on image caption generation. For this project I worked with the Microsoft Common Objects in Context dataset. I had 80,000 training images with around 5 captions each and 40,000 images in my validation set. I held out 4,000 of these validation set images as my test set to make my results comparable to Google's original show and tell paper. I evaluated all the generated captions using the metrics reported by state-of-the-art papers, namely Blue4, Meteor, and Cider. More information about these metrics can be found under the dataset section in my poster. Let's talk about models. My model specifically uses the pre-trained 22-layer convolutional neural network, the Google Net from 2014, to extract a vector representation of an image. And then I used an LSTM network to decode and generate captions from this representation. In figure 1 in the poster, we can see that we feed in an image and then a special start of sentence token, and then we train the model to predict the word at time t+1 using the hidden state at time t. In terms of experimental findings, I tuned the model using dropout probabilities and the number of LSTM layers. My best model, which is a 2-layer CNN-LSTM model with 75% keep probability for dropout between the LSTM layers, handily beats the random and nearest neighbor benchmarks on all metrics. It beats humans on the Blue4 metric and is within 3 to 4 Cider and Blue4 points away from Google's state-of-the-art results. Qualitatively, on the top right-hand corner of the poster, we can see that the model generates sensible captions. It recognizes, for example, that flowers are on a table and that a baseball player is swinging a bat at the ball. I also identified conditions under which it will get confused and make mistakes. For example, in the third image, it thinks that the man holding a camera is actually holding a cell phone, and in the fourth image, it thinks a teddy bear is actually a cat. These are due to these being relatively rare cases in the dataset. Most people in the dataset are holding cell phones in their hands and taking selfies in that posture, and cats are far more common than teddy bears in the dataset. The next thing that I did was to study hidden states. And to study them, I generated the hidden state of the LSTM after the previous emitted word had been fed back into the model. Concretely, I generated a word at time t, then fed it back into the model at time t+1, and recorded the hidden state at t+1 as a result. I then projected all of these hidden states down to 2 dimensions using t as an a. And then I plotted the hidden state for each sentence. What you see in figure 3 are the sentences. The first sentence is a plate of food with a sandwich and a salad. And the second sentence is a bowl of soup with a spoon and a bowl of soup. Now we can see that from figure 3, the words bowl and plate, as well as food and soup, which are semantically very close to each other, both move the hidden state in similar directions, which means that semantically close words are moving the hidden state in similar ways despite different previous contexts. For example, different images, different image vectors, or different previous generated words. Now the paper that I've uploaded also contains additional examples that I found in the dataset of this phenomenon. Now I've put together a quick demo that allows you to caption any image automatically. What I've done is that I've saved a picture of a pizza in an images folder. Here's the image. What we're going to do is to run the caption image script, and if we give it a couple of seconds, it loads in our best model. We are then going to do a forward pass in the of the CNN, and then if we give it a couple more seconds, it starts to generate the caption. So the generated caption is a pizza with cheese and cheese on a table. You know, it's not perfect, it's a little bit awkward in its phrasing, but semantically I think it captures most of what we see in the image. And you can download this demo at my GitHub repo. Now, in conclusion, we've almost matched the state-of-the-art numbers on the MS COCO dataset with thorough hyperparameter tuning. We have produced a model that generates captions automatically, sensibly, And we also showed that the model learns semantically meaningful interactions between word embeddings and hidden states. Thank you.